Okay, this is section 4.4 of the JV Stats class. It's actually chapter 15 in the book. We have small chapters in that particular book. And this is on probability models. Okay, like I always say, you need to stop the video quite a bit to write the answers down. Some people will want to do the problems ahead of time and then check this for their answers. So there's a lot of calculations here. So let's get started, all right? So the first thing is we got the definition of a random variable. A random variable is just simply lists all the possible outcomes. And then the probability model identifies the probability of each outcome. And the examples will speak for themselves. So examples, a single roll of a die. You got a 1 through a 6. Notice that 1/6 is the probability of each one. So I've listed them all. And this will add to 1, by the way. All the probabilities have to add to 1. When you roll 2 dice, you can get their sum. You can get a 2 through 12, okay? 2s and 12s are hard to get. 7s are really common, as you can see. If you add all those fractions, you will get 36 out of 36, okay? Now, 1A, okay, we're going to construct these just based on what we're reading. There are only 4 problems that you're unsure about on the practice test. The rest are guaranteed. The probability that you miss all 4 is 15%, miss 3 is 18%, miss 2 is 21%, and miss 1 is 35%. Create a model for all the mistakes, okay? I don't think 0 was listed. I think it was 4, 3, 2, and 1. So I had to go 100% or 1 minus the summation of these to get that answer. Okay. And then B, you roll a die. If it comes up a 1, you get $10. If it comes up an even number, you get $1. Otherwise, you get 0. Okay, and this is what I've created right here. Okay. So I put the fractions there and the decimals just so you know. Okay. Part C. And again, you'll have to stop and check this out. A coin will be flipped until it shows a heads, but we will stop after the 4th flip, even if it doesn't happen. We're going to stop. Okay, fine. So if you get a heads in the first try, it's 25%. If you get a heads in the second try for the first time, that would be 0.5 times 0.5. And this is 0.5 times 0.5 times 0.5, 3 of them. And then they'll stop after the 4th one. So that's the remaining number. That's a little tricky, I think. C and D are a little tricky. These would not be test items. D is pretty hard. It goes to prior knowledge, getting into combinations and stuff. A box contains 12 light bulbs, 4 of which are defective. You choose 3 bulbs at random. Create a probability model for the number of good bulbs you get. All right, so this one is 0 good ones and 3 bad ones of the 4 that are defective. This is 1 good one and 2 bad ones, etc. Okay, so you end up with these fractions here, which is these decimals. Okay, and those will add to 1, by the way. All right. All right, next section, again, you need to pause that and check that out. Next section is calculating the mean and the standard deviation. Nice. The expected value is called the mean. It's called the expected. Now, if you flip a coin 4 times, you are expecting 2 heads. That doesn't mean you'll always get 2 heads. That means that's the average. Expected is the average. Okay, I think the expected number of children per family is like 1.98 or something like that these days. It's a little bit under 2. Okay, in America, it's less than the replacement rate. I read that somewhere. All right. Remember, the variance is the square of the standard deviation. We don't use that a whole lot in this class, but we do use the standard deviation, which, if you recall, means the typical distance from the mean. It is a very long formula. It's not hard, it's just long. X sub I means every individual number. mu is the mean, which is the expected value up here. And then you're going to multiply it by all the probability of each one. I'm going to walk you through this and you're going to find it really easy. Okay. All right. For 2A, let's walk through this. Find the mean and the standard deviation for each situation. So for the mean, you're going to multiply every number times its probability and you're going to add it together. And you can see that is done here, although I did it reverse. I put 0.4 times 1, but it's the same thing. Okay. That's the mean. Then the standard deviations really takes a long time. Notice 1.7, or the mean, right here, the mean, is written 1 time, 2 times, 3 times. It's because you need it done 3 different times. So you take each number, 1, 2, and 3, and go 1 minus the mean squared. Notice that is done 3 different times. And then multiply it by its individual probability of happening, add it together, and then square root it. Okay? I'll walk through that again on this one. Here's the mean called mu. You're going to multiply each number by its individual probability. Hopefully you can see that there. Each number by its individual probability. Okay? Then you're going to take each number, you're going to subtract the mean, you're going to square it and multiply it by its probability. Notice that the mean of 7 is written 1, 2, 3, 4 times because it needs it for every one of them. So you're going to take every number, 0 minus 7 squared times its probability of happening. And then 5 minus 7 squared times the probability of its occurrence. And then 10 minus 7 squared times the probability of its occurrence. And then 20 minus 7 squared times the probability of its occurrence. All right. So this thing has a mean of 7, but it's got a fairly high standard deviation of almost 6, okay? Because that 20 is so different, it creates that number. All right. Now, for the next few of these, the next 4, it goes off of what we have up here in A, B, C, and D. So I'm not going to walk through it, but I'm going to stop here. And I'm just going to, I would stop the screen and just allow yourself to see this. Notice that on C, look how long this is. This is just absolutely awful. Some of these are really long. So they're kind of torturous, but okay. So again, I would kind of check those out. Let's see here. Oh yeah, I gotta squeeze that. I gotta get that in a little bit better. There we go. Because I cut that part off. Okay, so there you go for C, D, E, and F. There's the formulas for that. You'll have to go back through those yourself. Okay, so pause the video at this point. Okay, for the next part, we're doing the binomials or Bernoulli trials. Okay, binomial. What is a binomial? Bi means 2. 4 things make a binomial. A coin flip is a great example, but 4 things make a binomial. I highlighted them. Each trial's got to be independent. Think a coin flip. Each flip's independent. The probability of success is consistent. Maybe not perfect, but consistent. Okay? And only 2 outcomes, success or failure, heads or tails, make or miss on our free throws. And you got to have a certain number of trials you're doing. Okay, so this is very related to Pascal's triangle, very much so. So the first thing we're going to do is figure out which of these are binomial. Okay, the first one, Mr. Nguyen randomly collects 80% of the homework. What is the probability he collects all the homework this week? Is this binomial? Okay, the first thing, is each week independent? Yeah, you can assume that. Check. Is the probability of success consistent? Yeah, seems like it's 80% a week. Okay, yes. Are there 2 outcomes? Yeah, he either collects it or he doesn't. And is there a fixed number of trials? Yeah, there's 5 days in a week. So that's basically binomial. I put IPOT because it's independent, probability of success, 2 outcomes, fixed number of trials. I mean, some people, I tell my AP stats class, I use the acronym POTI. People remember POTI, okay, but whatever. Okay, B, how many text messages will you receive in the next hour? Okay, is this independent? Probably not, because I think, one friend on a group chat might trigger the other one, okay? Is the probability of success consistent? Not really. Is there a fixed number of trials? Not really. This thing's just simply not binomial at all. This is no way, okay? The next one, you can answer 75% of any math problem. How likely is it you won't get a correct answer until the 4th? Here's the problem. It is Bernoulli in a sense, but it doesn't have the fixed number of trials, so it's not binomial, okay? Because it doesn't get it, you won't get it right until the 4th question. You could get it right on the 1st, 2nd, 3rd. This is actually considered a geometric distribution, just so you know, okay? All right. Now, the calculation of these, okay? Pretty cool. I'm going to do these all 2 different ways, by hand and then on the calculator. This is really cool. Are you going to like these, okay? All right, so the first one, 15% of males are left-handed. Sweet, okay? Find the probability that in a group of 16 randomly chosen males, there's exactly 3 lefties. Exactly 3. Now, this is how you would do it using the old school formula. 16 choose 3. So there's 3 lefties, meaning there's 13 non-lefties. And this is binomial because you're right or left-handed, set number of trials, okay? You're going to go 0.15 to the 3rd for your 3 lefties. And you're going to do 0.85 to the 13th, which is your 13 righties on that. Notice that 3 and 13 have to add to make 16. Okay, so this and this have to add to make the n. Okay, and then these are complements, of course, because it's success and failure. Success is left-handed and failure is right-handed in this case. Okay, but there's a really cool way to do this on the calculator. I wrote it out here. Let me show you how to do this. Okay, this is pretty cool. Okay, so every calculator is different. So let's try this. You're going to go second distribution, which is the vars button, second vars. And you're going to go down to binomial PDF. PDF means exactly. It stands for probability distribution function. It means exactly. So hit enter. Every calculator is different. Mine says how many trials, 16, probability of success, 0.15. And you're looking for exactly 3 lefties. Now, in some calculators, you'll have to do this. You'll have to type, let me write this out, okay? You'll have to type in trials here, probability here, and then number of successes there, okay? And you have to put commas in between. Everybody's calculator is a little different. And bam, hit enter. And there's your answer. Pretty cool. Very cool. All right, let's go to the next one, shall we? All right, in a given city, the estimated rate of DUI-related accidents is 2 every 15. It's a lot. Find the probability that investigating 12 random accidents, there are exactly 6 DUI-related accidents. Exactly 6. All right, no problem. Now, this is how you do it the old school way. Okay, which you can do if you want. You can go, what was this, 12 accidents, exactly 6. So 12, choose 6, right? Times 2/15, which is, by the way, that's 0.133. 2/15 to the exactly 6 to the 6th times 13/15 to the 6th as well. Now, again, the features of this to remember are that this number right here, 6, and this number right here, they have to equal n, which I'm circling, that's 12, okay? And then these two are complements, and I've written one of them wrong. I'll get it. I just was missing a 1. 13/15. There we go. That's better. Okay. All right. Now you're probably going to go the shortcut way, which is fine. So let me clear that. So on the shortcut, exactly 6, that's PDF, probability distribution function. So I had the old one, the whole model set up there. So second, distribution, binomial PDF. It was 12 trials. Probability of success is 2/15. And then we want exactly 6. And again, you may have to type it in on your calculator using commas. Okay, and hit enter. Not real likely. If you think about it, what's the expected number on this one? I'm going to do this real quick. So you have 12 accidents at a 2/15 rate, right? So I'm going to go 12 times 2 divided by 15. We're expecting about 1.6 of the 12 accidents to be DUI related. We're asking for exactly 6. That's a pretty big gap between 1.6 and 6. So that's why the probability is so low. It's a less than 1% chance this would happen. If you saw a spike like this, you might say, wow, 6 of the last 12 have been DUI related. What's going on? That's a little unusual. You might actually think that, which would be an inference kind of thing. You're inferring, making a judgment. Okay, let me clear this for the next time. All right. Okay, next one. Exactly 5 lefties. I noticed that I'm going back and forth on this. I'm not doing this in any particular order. That's kind of weird. Let me go ahead and stick with this differently. I'm going to go ahead and do 4A all the way through this time, and then I'll do B. Wow. Okay. Exactly 5 lefties. So exactly 5 lefties, if you recall, would be written as 16 choose 5 times 0.15 to the 5th times 0.85 to the 11th. Sound good? All right, so we're back to our lefty problem. Why did I do that? Yeah, some people's kids. Okay, so exactly 5 lefties. All right, let's try it. No big deal. So exactly 5 would be second distribution, binomial PDF exactly. So that's 16 trials. 0.15 is the percentage of lefties. And how many was it? It was exactly 5. Oops, X value is 5. There we go, 5. Come on, get your head together. All right, about 5%. 0.05. We usually get a 4 spots. 0.05 by 5. Okay, cool. All right, next one. Got issues here. Okay. At least 5 lefties. At least 5. Wow. At least 5. Now let's just listen to this. At least 5 is 5 or more. 5 or more. So that's 5 or 6 or 7 or 8 or 9 or 10 or 11 or 12 or 13 or 14 or 15 or 16. That's a pain. Okay. There is a function on your calculator that does this. It's really cool. It's the Cdf button. And Cdf stands for Cumulative Distribution Function. But it's basically nicknamed the or less button. So you got to get the complement of 5 or more. At least 5 includes 5 or more. The complement of 5 or more is 4 or less. So the CDF will add together 4 or 3 or 2 or 1 or no lefties. So that's what I'm going to do. I'm going to type that thing in. I won't do it because you can see it right here. This is already done for you. But it's that CDF button. Actually, I will do it. I'm going to do it. Okay. So let's check it out. And it's one. Okay. So second distribution. I'm going to go to binomial CDF 16. The trial success rate is 0.15 and it's 4 or less. And then I'm going to go 1 minus second answer because I want 5 or more. Okay. Pretty cool. CDF, Cumulative Distribution Function. Okay. All right. Okay. No more than 3 lefties. No more than 3 lefties. Okay. No more than 3 means 3 or less. Okay. It does include 3. It does include it. No more than 3 includes 3. All right. So that's going to be the CDF button, but I don't got to go 1 minus because that's exactly the way I want it. So this will add up, cumulative distribution function will add up 3 or 2 or 1 or none. Okay, that one I won't do. You can see that one right there. Go ahead and try that on your calculator. Okay. All right, back to my DUI problem that I started on. Exactly 1 DUI related accident. Exactly 1 is a PDF one, okay? So again, this is 2/15 right here. The old school way of writing this out would be 12 choose 1 times 2/15 to the first times 13/15 to the 11th power. Okay? Sound good? All right. Perfecto. And then you can punch that in, you'll get it. All right. Next one, at least 3 DUI accidents, at least 3. That's 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10 or 11 or 12. That's a lot to add up. But there's a button on the calculator. Remember, it only does or less. CDF stands for Cumulative Distribution Function. So the complement of at least 3 is 2 or less, 2, 1, or 0. Okay, so if I can go 1 minus 2, 1, or 0, I'll be left with 3 or more, which is called at least 3 in this case. Okay, so let's try this on the calculator. All right, so let's try this. Okay, let's go. Second distribution, binomial CDF 12. 2 divided by 15, and then 2 or less. Sound good? And then I'm going to go 1 minus that. 0.2084. 0.2084. All right, very cool. I think that's right. Yeah, 8384. Okay, perfect. All right, that is almost it. The last one, at most 5 DUI related accidents. At most means 5 or less. So you have to add together 5 or 4 or 3 or 2 or 1 or none. Okay, and that CDF button will do it. It'll add those all up for you. So remember, this is 2/15 right here, 0.3133. Okay, and then there's the 5. All right. Hope that helped. That's a pretty cool lesson. So probability, lesson 4, I believe. All right. Thanks for watching.